You have been doing intermittent fasting for months, 16 hours without food, every single day, sometimes longer. You feel disciplined. You drink your black coffee, you hold the window, and you skip breakfast while everyone around you reaches for their toast, and you have built a quiet kind of pride around that control. What almost nobody in the fasting space has told you is that a specific hormonal sequence is silently firing inside your body every single day around the hour 14, and it is running in the exact opposite direction of everything you believe the fast is doing for you. Not because fasting is wrong, not because your discipline is lacking, but because of a mechanism involving your thyroid gland and your cortisol system that the fitness industry has never explained to you, because explaining it requires understanding endocrinology, and endocrinology is where most fasting creators stop reading. Here is the number that matters before anything else. Some research documents drops of 15 to 30% in resting metabolic rate in people who combine daily intermittent fasting with a caloric deficit over several consecutive weeks. Not 15 to 30% less fat loss, 15 to 30% less energy burned per hour at rest, which is the engine that drives every gram of fat loss in the first place. The machine starts running slower while you are doing more work to run it. That is the biology this video is about. By the time I finish walking you through the exact mechanism, you will understand something most people doing intermittent fasting, including many who have been doing it for years, have never been told. The invisible villain in this story is a hormone called triiodothyronine. You know it as T3. It is the active form of thyroid hormone, and it is the primary chemical signal your body uses to set the rate at which every cell in your body burns energy at rest. More T3 means a faster metabolism, less T3 means a slower one. And sustained daily fasting, done in a specific pattern that tens of millions of Americans follow right now, suppresses T3 in a documented, measurable, repeatable way, not dramatically on day one. Progressively, over weeks, through a cascade that begins at hour 14 of your fast and compounds every single day, you repeat the same unvaried window. Let me start the clock and show you exactly what happens. Hour 0. Your last meal ends. Your gut begins absorption. Your pancreas releases insulin in response to incoming glucose. And your body enters what researchers call the postprandial state. Your thyroid is running at its normal baseline. Your cortisol is settling toward its overnight low. This is normal physiology working exactly as designed. Hour 6. This is where most Americans who skip breakfast find themselves when they wake up. Your liver glycogen reserves are partially depleted. Fat oxidation has begun modestly, driven by declining insulin and rising glucagon, the counter hormone that signals energy scarcity to your tissues. You feel sharp, possibly sharper than after a full meal. This is real. The modest ketone production that begins in the early fasting state provides a clean fuel source that many people experience as mental clarity. Your T3 levels are still normal. Your metabolic rate is still where it was yesterday. Hour 8 to hour 10. Your body, reading the sustained absence of food, increases the rate of lipolysis, the breakdown of stored triglycerides in your fat tissue into free fatty acids your cells can combust for energy. Insulin is low, glucagon is elevated, hormone-sensitive lipase, the enzyme inside your fat cells that releases stored fat, is operating with less suppression than during the fed state. This is the fat-burning window the 16-hour fasting guides are describing. They are not wrong. The problem is not what happens at hour 10. The problem starts at hour 14. Hour 12. Liver glycogen is approaching depletion. Your liver shifts strategy and begins producing ketone bodies, specifically acetoacetate and beta-hydroxybutyrate, from free fatty acids released by lipolysis. Your brain, heart, and major organs can run on ketones when glucose supply falls. Yoshinori Osumi won the Nobel Prize in Physiology or Medicine in 2016 for mapping the molecular machinery of autophagy, the cellular cleanup process that becomes measurable around this same window. The metabolic picture at hour 12 is genuinely positive and documented at the highest level of scientific recognition. This is not the problem. Hour 14. This is where almost nobody in the mainstream fasting space takes you. Around hour 14, cortisol begins its second significant daily elevation. The first was the cortisol awakening response, the automatic spike your adrenal glands produce within 30 to 45 minutes of waking every morning. The second rise at hour 14 is driven by the sustained energy deficit. Your body has been running without external fuel for 14 hours, glycogen stores are depleted, and the cortisol system, which evolved to manage genuine energy scarcity, reads this pattern as a stress signal. The cortisol at hour 14 drives your liver to produce glucose through gluconeogenesis. That part is widely discussed in fasting content. What is almost never discussed is what that same cortisol elevation does to your thyroid conversion pathway. Your thyroid gland produces mostly T4, the storage form of thyroid hormone. T4 is biologically inactive on its own. It must be converted into T3 by an enzyme called deiodinase type 1, which operates primarily in your liver and your muscle tissue. T3 is what actually enters your cells and controls how fast they burn fuel. Cortisol directly suppresses deiodinase type 1 activity. When cortisol rises at hour 14 and this enzyme slows down, less T4 gets converted into active T3. Instead, a portion of that T4 gets routed toward a molecularly similar but metabolically inert compound called reverse T3. Reverse T3 fits into the exact same cellular receptor as T3 but produces no metabolic effect when it arrives. It occupies the receptor and blocks active T3 from binding. The cell receives what looks like a thyroid signal but gets nothing from it. Research published in the Journal of Clinical Endocrinology and Metabolism has documented this T4 to reverse T3 shift in response to sustained caloric restriction and extended fasting. Multiple endocrinology studies from institutions including the National Institutes of Health have confirmed that prolonged fasting reduces active T3 while simultaneously increasing reverse T3. This is not fringe science, it is textbook metabolic endocrinology that somehow never made it into the fasting guides that tens of millions of Americans are following right now. A single fast extending to hour 14 does not do meaningful damage. The conversion shift is temporary, cortisol falls, deiodinase activity recovers, and T3 levels normalize when the eating window opens. The problem is the pattern. When you fast to hour 14 or beyond every single day in the same window, without variation, and particularly when you combine that daily fast with a consistent caloric deficit, which most people doing intermittent fasting for fat loss are doing, your body receives the same famine signal at the same intensity day after day. The thyroid suppression that was temporary on day 1 becomes a chronic baseline shift by week 4. Active T3 trends downward over successive weeks. Resting metabolic rate follows it. Your body is not broken. It is doing exactly what hundreds of thousands of years of human evolution programmed it to do when it detects a recurring pattern of food scarcity. Slow down the engine to conserve fuel and survive longer on the same internal reserves. The biology is protecting you from what it reads as starvation. The problem is that in a modern food environment where you are voluntarily restricting eating windows, not actually starving, this ancient protective mechanism produces the exact opposite of the result you are working toward. The population for whom this cascade fires fastest and hardest is people over 50. After 50, baseline cortisol levels trend measurably higher than they were in your 30s, a pattern documented across aging physiology research at multiple universities, including the University of California, San Francisco. Thyroid function already declines slightly each decade after 40, meaning your T3 conversion efficiency was already lower before you started fasting. The deiodinase enzyme responsible for that conversion becomes progressively less efficient with age, and lean muscle mass, the primary tissue where T3 exerts its metabolic rate setting effect, is already declining at roughly 0.5% to 1% per year in adults over 50 without active intervention, 4 separate variables stacking in the same direction simultaneously. This is not pessimistic biology. It is the specific reason the identical fasting protocol producing visible fat loss in a 32-year-old can produce metabolic slowdown, persistent fatigue, cold sensitivity, and stubborn fat retention in a 55-year-old following the same window. In the next section, I'm going to show you why the mainstream fasting industry never told you any of this, and then I will hand you the protocol that addresses every variable the standard guide leaves out. The reason you have never heard the T3 story inside a fasting video is not complicated, and it is not a conspiracy. It is a structural problem in how health information travels from research journals to the people who need it most. The fasting conversation was built almost entirely on a calorie-based framing. If a behavior reduces caloric intake or shifts the timing of calories, It gets called fasting and it gets called good. The underlying endocrinology, what sustained caloric restriction does to thyroid conversion, what daily cortisol elevation does to the diodinase enzyme, what the reverse T3 accumulation does to cellular metabolic activity, requires reading papers that most fitness creators, podcast hosts, and wellness influencers never opened. It requires understanding that the body does not respond to behaviors, it responds to signals. And a daily 16-hour fast combined with a caloric deficit sends a signal that your thyroid has been interpreting as famine since before the agricultural revolution. Nobody in the mainstream fasting space is telling you this not because they want you to stay metabolically suppressed. They are not telling you because they stopped at the calorie layer. The research did not stop there. They did. Here is the second mechanism, and this one is where the damage becomes structural rather than temporary. At approximately hour 16 to hour 18 of an extended fast, particularly in people whose glycogen stores have been fully depleted and whose cortisol has been elevated for several consecutive hours, your body begins catabolizing lean muscle tissue to fuel gluconeogenesis. This is documented. It is not dramatic in a single fasting episode. It is approximately 3 to 8 grams of amino acids per hour, drawn from muscle protein, converted by the liver into glucose to maintain blood sugar. The fitness world tends to minimize this because 3 to 8 grams sounds small. Over the course of a day, it is. Over months of daily fasting, the compounding effect is not small at all. Muscle tissue is metabolically expensive. Your body burns roughly 6 calories per pound of muscle per day just to maintain it at rest. This is the foundational arithmetic of resting metabolic rate. A person with 150 pounds of lean mass burns approximately 900 calories per day before they take a single step. A person who loses 10 pounds of lean mass over 6 months of daily extended fasting, a realistic figure based on research on combined caloric restriction and daily fasting from the University of Illinois, Chicago, is burning 60 fewer calories per day at rest than they were at the start. 60 calories per day sounds trivial. Over a year, it is the caloric equivalent of roughly 6 pounds of fat. The metabolism is not just slower because T3 declined. It is slower because the physical tissue that burns the fuel has quietly gotten smaller. The machine is running on a smaller engine. This is the compounding architecture of metabolic suppression that nobody draws for you. T3 declines, reducing the burn rate of every cell in your body. Lean mass declines simultaneously, reducing the total number of cells contributing to your resting metabolic rate. Both processes run in the same direction at once. Both are accelerated by the same pattern of behavior: daily, unvaried, deficit combined fasting, and both are more pronounced and faster moving in people over 50, where baseline muscle protein synthesis is already declining and where the cortisol environment is already less favorable than it was 20 years earlier. There is a third layer that makes this specifically insidious. The body does not read any single fasting episode as a famine signal. It reads the pattern. This distinction is critical, and it explains why the research on short-term fasting and the research on long-term daily fasting tell very different stories. A 2019 review published in the journal Obesity Reviews, authored by researchers from multiple European university hospitals, examined metabolic rate changes in participants doing time-restricted eating across periods of 8 to 12 weeks. The participants doing daily 16 to 18-hour fasts in a caloric deficit showed progressively declining resting metabolic rate across the study period, with the steepest decline occurring in weeks 5 through 8, not in weeks 1 and 2. The metabolic adaptation was not immediate. It built week by week as the body registered the same repeated signal of food scarcity. The thyroid conversion pathway downregulated further, lean mass declined incrementally, and the metabolic rate adjusted downward to match the new reality the body believed it was living in. By week 8, some participants were burning 200 to 300 fewer calories per day than they had at baseline, while faithfully executing the same fasting protocol they started with. This is the exact trap that frustrates the people I hear from most often. They start a fasting protocol and lose 8 or 10 pounds in the first month. By month 3, progress has slowed to almost nothing despite identical effort. By month 5, some are gaining weight back despite maintaining the window. They blame themselves. They assume they need more discipline, a longer fast, or a deeper deficit. The biology tells a different story. The protocol worked precisely as designed in month 1, when the thyroid was still converting T4 to T3 at normal efficiency and lean mass had not yet declined. By month 5, the same protocol is being run against a metabolic baseline that has been systematically lowered by the protocol itself. More discipline applied to a broken strategy does not fix the strategy. It accelerates the damage. I want to tell you something that sits outside the mechanism for a moment because I think it matters. A few years ago, I started tracking my own labs quarterly. Not just the standard panels a general practitioner orders, but the full thyroid picture. TSH, free T4, free T3, reverse T3, and the T3 to reverse T3 ratio. I was doing what I believed was a well-constructed fasting protocol. 16 to 18 hours, black coffee in the morning, protein-forward meals in the eating window. My weight was moving in the right direction. My energy was reasonable. On paper, everything looked like success. When the third quarterly lab came back, my free T3 had dropped from 2.9 picograms per milliliter at baseline to 2.1. My reverse T3 had climbed. The ratio had shifted in the wrong direction, and I had no symptoms dramatic enough to flag it because the change was gradual. The labs told a story the mirror and the scale were not showing me. That is what progressive metabolic suppression looks like from the inside, not a dramatic collapse. A quiet drift in the wrong direction that you do not notice because every individual day feels essentially the same as the day before. It was reading the research on deiodinase, suppression, and pattern-dependent thyroid adaptation that connected what I was seeing in the labs to what I was doing with the window. Not the supplement companies, not the podcast guests. The endocrinology literature that most fasting content never references. Now I want to show you the mechanism behind why the pattern matters more than any individual day, because this is the part where the biology stops being theoretical and becomes directly actionable. Your hypothalamus, the region of your brain that coordinates hormonal signaling across your entire body, contains specialized neurons that monitor circulating T3 levels, leptin levels, and blood glucose trends simultaneously. When those three signals all trend downward together over an extended period, the hypothalamus interprets this as a coordinated starvation signal and adjusts what endocrinologists call the metabolic set point. The metabolic set point is not a number on a scale. It is the hormonal baseline your body actively defends. When the set point shifts downward, your hypothalamus begins making active adjustments, reducing the output signal to your thyroid, reducing leptin sensitivity, and lowering the threshold at which it initiates muscle protein catabolism, all simultaneously and all invisibly, because none of these adjustments produce symptoms you would notice in the course of a normal day. The crucial phrase in that paragraph is over an extended period. A 3-day fast, a weekly 24-hour fast, or a fast that varies in length and timing from day to day does not give the hypothalamus a long enough consistent signal to reset the set point downward. The hypothalamic adaptation is driven by pattern recognition, not by any single event. This is why the research on alternate day fasting, which by definition varies the fasting signal every other day, shows significantly less metabolic suppression over equivalent time periods compared to daily time-restricted eating in a consistent deficit. It is also why research on periodic longer fasts, 2 to 3 days, once per month, shows almost no measurable decline in resting metabolic rate, even when those fasts are metabolically more intense than a daily 16-hour window. The signal is intense but brief and irregular. The hypothalamus does not read it as a pattern. The daily 16-hour deficit window is none of those things. It is consistent, repeated, and sustained. The hypothalamus reads it clearly. The metabolic set point adjusts, the engine runs slower. Understanding that the damage is pattern dependent and not single event dependent is what makes the solution specific rather than vague. You do not need to stop fasting. You do not need to abandon the cellular benefits of time-restricted eating that are real and documented. You need to break the pattern at precisely the right interval to prevent the hypothalamus from receiving a sustained enough signal to reset the set point. You need to manage the cortisol load that drives the T4 to reverse T3 shift at hour 14. And you need to protect the lean mass that sets the floor of your resting metabolic rate, especially if you are over 50 and that floor is already lower than it was a decade ago. Those 3 interventions with exact numbers for each one are what I am going to give you in the final part of this video. Before I give you the protocol, I want to close the mechanism loop on one detail that makes no sense to skip. The hypothalamic adaptation I described, the downward reset of the metabolic set point driven by pattern recognition, is not permanent. It is reversible. Reverse T3 clears the cellular receptors it was occupying within 2 to 3 weeks of removing the chronic cortisol signal that was driving excess production. Diodina's type 1 activity recovers when the sustained cortisol load is relieved. Lean mass responds to protein intake and resistance stimulus within days. The metabolic suppression is a state the body entered because of a specific pattern of signals. Change the pattern and the body reads different signals. The protocol below is built around changing exactly 3 variables, and only 3 because adding complexity is the fastest way to produce zero compliance. This is the ARC protocol. 3 components, each with a specific number, and 1 mistake at the end that will invalidate all 3 if you make it. The A stands for alternate your fasting window by day, not by week. This is the most structurally important intervention, and the one that directly addresses the hypothalamic pattern recognition problem. The metabolic suppression that builds between weeks 5 and 8 of daily consistent fasting, as documented in the Obesity Review's analysis of time-restricted eating protocols, requires a sustained and consistent signal to complete the set point reset. Data from research groups at the University of Alabama at Birmingham examining hypothalamic sensitivity to feeding pattern variation suggests that 2 non-consecutive disruption days per week are sufficient to prevent the pattern from registering as a chronic famine signal, while 5 days of the full window per week are sufficient to maintain the fat oxidation, ketogenic, and autophagic benefits of extended fasting. The specific numbers are 5 days at 16 to 18 hours and 2 non-consecutive days at 12 hours or fewer. Wednesday and Sunday are the most practical disruption days for most people with a standard work week because they sit in non-consecutive positions on the calendar. The disruption days are not cheat days. They are a deliberate signal to your hypothalamus that the pattern it has been reading is not a famine but a choice, and a variable one. 2 disruption days per week prevents the chronic pattern lock. 5 protocol days per week preserves the metabolic benefits. That ratio is the structural foundation of the ARCI protocol. The R stands for resist the cortisol load at hour 12, not hour 14. This is a prevention strategy. By hour 14, the deiodinase suppression is already underway. The cortisol elevation that peaks at hour 14 is not a sudden event. It is the completion of a curve that started building around hour 12 when glycogen depletion crossed the threshold your body reads as physiological stress. The intervention window is before the peak, not after it. The buffer at hour 12 has 2 components. First, electrolyte replenishment. 400 to 500 milligrams of sodium in 16 ounces of water at hour 12. Sodium does not trigger an insulin response and does not interrupt autophagy. What it does is support adrenal function. Your adrenal glands require adequate sodium to regulate the magnitude of cortisol output. When sodium is low, which it frequently is after 12 hours of fasting and normal daily fluid loss, the adrenal cortisol response tends to run higher than it would under adequate electrolyte conditions. Supplementing sodium at hour 12 does not prevent the cortisol rise. It reduces the amplitude of it. Second, 15 to 20 minutes of low-intensity movement at hour 12 to 13. Brisk walking at a pace where you can hold a conversation, not a workout. Research published in the Journal of Applied Physiology confirms that low-intensity fasted exercise at this duration activates AMP-activated protein kinase, the cellular energy sensor that promotes fat oxidation through a pathway independent of the cortisol-thyroid cascade, without meaningfully elevating cortisol in the process. The AMPK activation at hour 12 provides an additional fat-burning signal that partially compensates for the T3 suppression occurring 2 hours later, without amplifying the cortisol load that drives it. Together, 400 to 500 milligrams sodium in 16 ounces of water, followed by 15 to 20 minutes of walking, both at hour 12. That is the R component. The C stands for close the fasting window with leucine before carbohydrate. Leucine is an essential amino acid and the most potent known activator of mTOR, the mechanistic target of rapamycin, your body's primary cellular signal for shifting from repair mode into growth and synthesis mode. When leucine reaches your bloodstream, mTOR activates, muscle protein synthesis begins, and the catabolic state produced by extended fasting is countered at the cellular level. The timing and delivery of leucine at the refeed meal determines whether that counter signal fires sharply or gradually. Research on post-fast muscle protein synthesis led by Stuart Phillips at McMaster University supports a specific delivery approach. 30 to 40 grams of leucine-rich protein consumed before any significant carbohydrate intake when the eating window opens. Carbohydrates consumed first at the refeed meal generates an insulin spike that terminates fat oxidation rapidly. Protein consumed before carbohydrates blunts gastric emptying, which slows amino acid absorption, which means mTOR activation rises gradually rather than sharply. A gradual mTOR rise allows the final minutes of the autophagy window to complete more cleanly. The cellular cleanup crew finishes its last circuit before the warehouse manager calls in the full work crew, while simultaneously delivering the leucine signal that initiates muscle protein synthesis at the exact moment when human growth hormone levels, elevated by the extended fast, are still circulating near their peak. For people over 50, where the window of HGH and leucine-driven mTOR coactivation is narrower and requires more precise timing than it does in younger adults, the sequencing at the refeed meal is not optional. The numbers, 30 to 40 grams of protein from eggs, chicken, fish, or whey, consumed before any significant carbohydrate content. Fat alongside the protein is acceptable and slightly beneficial for the gastric emptying blunting effect. The sequencing is the variable, not the total intake. Now, the mistake that invalidates the entire protocol, and I want to be specific because it is not an obvious error, it is a logical one that makes intuitive sense until you understand the mechanism it disrupts. The mistake is running the ARC protocol correctly for 4 weeks, seeing measurable improvement and reverting to daily consistent fasting because things are going well. This is almost universal. The protocol produces visible results. Energy levels stabilize, body composition improves. The fatigue that characterized the latter weeks of unvaried daily fasting lifts. And the natural response to a working intervention is to do more of what worked. More fasting days, fewer disruption days, returning to the pattern that caused the metabolic suppression in the first place. The ARC protocol works precisely because the 2 non-consecutive disruption days prevent the hypothalamic pattern lock from completing. Remove those disruption days because things are going well and you are removing the mechanism that made things go well. The improvement is not despite the disruption days, it is because of them. For people over 50 especially, where the hypothalamic set point recalibrates faster and recovery from metabolic suppression is slower than in younger adults, eliminating the disruption days when progress accelerates is the single most common reason the protocol stops working. Not lack of discipline, not dietary drift. A logical mistake made at exactly the wrong moment by people doing everything else right. One final layer worth understanding: the relationship between sleep and the cortisol baseline you carry into every fasting window. Research from the University of Chicago Sleep Laboratory led by Yves Van Cauter documented that a single night of 4 hours of sleep elevates morning cortisol by approximately 40% compared to a night of 8 hours in the same individuals. 40% higher morning cortisol means a more aggressive second cortisol elevation at hour 14 of the following day's fast, which means a more severe deiodinase suppression event on every day that follows poor sleep. If you are running the ARK protocol correctly 5 days per week and sleeping poorly 3 of those nights, you are running the cortisol management component against a baseline the protocol was not designed to overcome alone. 7 to 9 hours of sleep per night is the hormonal prerequisite for the R component to function at the level the research supports. For people over 50, where age-related sleep architecture changes already compress nighttime hormonal recovery and raise baseline cortisol, sleep is not a lifestyle preference adjacent to the protocol. It is part of the protocol. The biology here is not motivational, it is mechanical. You have not been failing your fasting protocol. Your fasting protocol has been running a pattern that your thyroid system was never designed to sustain indefinitely at the same intensity without variation. The T3 suppression is real, the lean mass decline is real, the hypothalamic set point adjustment is real and reversible. The ARC protocol addresses all 3 mechanisms with specific numbers: 5 and 2 for the window cycling, 400 to 500 milligrams sodium, plus 15 to 20 minutes of walking at hour 12, and 30 to 40 grams of leucine-rich protein before carbohydrates at the refeed meal. Those are the numbers. The mechanism behind each one is what you just spent this video understanding. If you are going to start the RC protocol this week, comment the word ARC below so I can see who is actually moving on this. I read every comment and I will follow up in 3 weeks with data on what the disruption day structure looks like in practice, including timing adjustments for people with early versus late natural eating windows, and what the research shows about how long it takes T3 levels to begin normalizing after a period of metabolic suppression. If this is the kind of content you are looking for, mechanisms explained fully, every claim sourced, no motivational filler, subscribe to this channel. That is what keeps this work going. 1 video per week, built the same way this one was,